Hello there, mathematician friends. I am here to talk to you about a process that is really important to understand because we use it in several different places, and that is completing the square. So the first two things I want to talk to you about very briefly are what does that mean and why would we use it? Okay, so completing the square in general is basically taking a polynomial expression, just whatever the polynomial may be, and putting it into a situation, getting it into a place where it can be written as a perfect square of something, meaning something like this. So we're really just manipulating the format of something. Another way of thinking of it is here we have an x squared. We have x's that are not squared. We want to put this into a situation where it's all inside of something squared. Because then, for one thing, we could maybe solve by taking the square root. But so this is a complete square, basically. This is something that is squared. And you can think of it actually as the complete square being what factors to be this. In other words, for instance, this is a complete square because it can be written like this. This is the factored form of that complete square. So that's the goal. Where do we use this? One place we use it is if we have a quadratic equation, and it's written in standard form, and we want to write it in vertex form. Now, I'm not showing you the process, but basically I rearranged things here so that I now have a completed square that is factorable as something squared, a binomial squared. I can do it with circle equations. Sometimes we use it with circle equations. Sometimes I show weird things on the side of my computer I don't mean to show, sorry. And another time we use it is if we want to solve an equation. Like, for instance, this one, it's not factorable. I could use quadratic formula, but instead I can complete the square so that I have it written as a nice perfect square trinomial and then factor it. And now I have that parentheses squared that I'm looking for. Sorry, I did not do this here. And that's what we get there. Okay, so this is when, and now I could solve this. I could go ahead and take the square root of both sides, and I could get my x. So this is why we use completing the square. Well, let's go ahead and talk about that process. All right. Now, the ones I'm going to show you in this video are sort of the simpler ones where my leading coefficient is 1, like this. That's a 1. We're not going to address the ones like this. We're just going to do the basic ones where my leading coefficient is 1. So that's why I've written completing the square when a is equal to 1. So my preparation is first I want to get it in standard form and equal to 0, preferably on the right-hand side. So this is what we mean by standard form. The next step is to move the constant term to the other side. The constant term is the c. So I'm going to subtract c from both sides, and then it looks like this. Now you'll notice I left a lot of space there because the last step I really like to have in there is to add some blanks, because what I'm going to do is I'm going to be adding something to both sides, and I leave a blank on both sides to remind myself, for one thing, to put it on both sides and to sort of get ready for that. So this is sort of the preparation. This is the preparatory part of getting ready to complete the square. Now we're actually ready to do the process of completing the square. Now, right now I'm showing it to you with letters. I'm going to come back on the same piece of paper and do it with an actual example with numerical values, so don't freak out about that yet. All right, so now you're ready to actually complete the square. First off, you're going to take half of b. That means the number that's in front of the x term, or in what we call the coefficient of the linear term. Now, taking half of a number is the same thing as dividing that number by 2. If I take half of 10, that's 5. That's the same as 10 divided by 2. So I'm going to rewrite take half of b as b divided by 2. And you'll see why as we get into some of the more complicated ones. It really helps to think of that taking half as putting it over 2. Then I'm going to take that value and I'm going to square it. And that's what I'm about to add to both sides. Now, where do I add it to both sides? That's what the blanks are there for. So I'm going to put in b over 2 squared on both sides. Okay, finally, I'm going to factor the left and simplify the right. Okay, so factoring the left, what's going to happen here? And I went ahead and I wrote an A, but we have already said my A is 1. So I'm going to just drop the A at this point because the A is not going to be anything on these. It's just going to be x squared at the beginning. So the left-hand side is always going to be x plus or minus, depending on what sign it is. Let's go ahead and just say plus at this point. B over 2 squared. It's whatever the sign, whatever you got right here. When you factor the left-hand side, that's the number that's going to be here. If you got a negative here, it's going to say x minus that. If you got a positive, it's going to say x plus that. And then you simplify the right however this simplifies. Okay? And then you're done completing the square. Now let me point out that this is an example that involves doing it in equation form. If I was doing it to rewrite in vertex form for an equation for a function, I might have a slightly different scenario. We're also only doing this for one variable. This is just the basic process, and this is how I'm choosing to show it to you. But I'll show you how that applies to different problems at the end of this video. So now we just need to go back through and do this with an actual example. Okay, so let's go ahead and do one. This is in equation form, and we're given an equation up here, and we are going to go through these steps. So first off, I need to get this in standard form. This is not in standard form. I can't see what A or B or C is until it's in standard form. So let me move this 2x over here and add the 28 to both sides. And here's what I've got. X squared plus 14x plus 33 equals 0. So that's in standard form. Now I need to move my constant term to the other side. My constant term is the 33. That means just the plain number. So I'm going to subtract it from both sides. If it was negative, I would add it. So this right here, this doesn't mean it's going to be negative. It means the opposite of C. So I've got x squared plus 14x, and on the other side I have negative 33. And then my next step is to add those blanks. I usually do that kind of all in one step. Running out of space over here though. All right, now I'm ready to complete the square. So this part right here is where I'm trying to complete the square. I'm trying to turn this trinomial, or really it's just a binomial right now, but I'm trying to make it 3 terms that are a complete square or a perfect square trinomial so that it can be factored as a binomial squared. The way to do that is what's right here. Take half of b. So that's 14 over 2. Okay, 14 over 2, I can simplify that 7. If this was an odd number, I would just leave it. If it was like 3 over 2, it'd be just 3 over 2. Then I'm going to square that, and that's what I'm going to add to both sides. So that's what goes in the blank. So plus 49 plus 49. Then I'm going to factor the left-hand side and simplify the right-hand side. When I factor the left-hand side, because of how we've set it up, the left-hand side will always, it's now a perfect square trinomial, which means it's going to factor as some binomial squared, and it's always going to work out to be x plus whatever half of b was. So x plus 7. So in other words, I could factor this by knowing how to factor and thinking about what 2 numbers multiply to give me 49 and add to give me 14 and so on. Or it's always going to work out this way, that this number is going to be half of this number. So if it's a weird number, it's helpful to know that. Okay? And on the right-hand side, I simplify. Negative 33 plus 49 is 16. So at this point, I have completed the square. There are several different things we could do with it from here. The 2 most common, if I was being asked to complete the square in order to solve, now I would take the square root of both sides. And I would get x plus 7 equals plus or minus square root of 16, that's plus or minus 4. Then I would move the 7 over, and we usually like to write it in front. It's like minus 7, but we usually like to write that in front of the plus or minus. And that means negative 7 plus 4, which is negative 3, and negative 7 minus 4, which is negative 11. And those are my 2 solutions. Now, what if I had been being asked, instead of solving, I was asked to write an equation in vertex form? Well, we could still do exactly everything we just did, and then at the end, move this over and say, okay, my vertex form for this equation is x plus 7 quantity squared minus 16. Because on vertex form, you really only have one side. You don't want to have two sides. There's also another way to get there, but this will work. You can do it either way. Okay, so with our examples, we're going to look at a couple of different contexts. One is sometimes I'm asked, what do I have to add to these in order to complete the square? And that's all I'm being asked to do. I'm not asked to go ahead and solve. I'm not asked to write things in vertex form. That's it, or a circle form or anything. I'm just being asked, what would I have to put here in order to make this a perfect square trinomial? And that's where I take half of b and square it. We wouldn't usually leave it like that. I would go ahead and write 25. So x squared plus 10x plus 25. And then sometimes we're asked to go ahead and rewrite that as a binomial squared. Well, that's x plus 5 squared. Remember, it's no accident that this number ends up right there. Let's do another one like that. Okay, what would I have to add here in order to make a complete square? Half of this is negative 9, and then that gets squared here. Negative 9 squared is positive 81. We're squaring the whole number, including the negative. Okay, so when we have this blank where we're trying to figure out what to add, or even when we're doing equations and we're trying to figure out what to add to both sides, it's always going to be a positive number because we got there by squaring something. So even if the something we squared was negative, when we square it, we get a positive. Okay, and then rewriting this as a binomial squared gives me that. Couple things to notice here. Whatever I got when I took half of b is what's here. And notice the sign comes with it. That's the other thing to notice. The only way this is going to be minus is if this sign right here is minus. If this sign right here was plus, this would be plus. They will always match. All right, let's do another one. Always feel free to pause and try things yourself before I work them out. All right, half of b means I'm taking negative 6 and dividing by 2. I remember I take this negative as part of when I'm looking for half of b. Half of b has to be the same sign as this. That's what I was talking about right up here. So that's negative 3. So I'm going to have negative 3 squared, which is 9, positive 9. And x minus 3 squared is what I get. If you have any doubts, you're like, that doesn't make sense. Why is that x minus 3? You can always check by multiplying it back out. Don't forget, though, that when you multiply out a binomial, you really need to think of it as this, a binomial squared. Excuse me. Anytime you have a binomial squared, this is what it means. It does not mean x squared minus 3 squared. Because when I multiply x minus 3 times x minus 3, I get 4 terms, and 2 of them combine so that I end up with 3 terms. There's the 4 terms I get. You could think of it as FOIL or distributive property that happened here. And the middle 2 terms combine, and this is what I get. So yes, that does match. So this is the factored form of my perfect square trinomial. Now, notice that all of these, when I took half of b, I've been taking half of an even number. Taking half of an even number is easy. Taking half of an odd number kind of freaks us out. So let's look at a couple like that. This is why I was telling you I like to write it as b over 2 instead of saying take half of b. Because when you do it with an odd number, b over 2, you can just leave it. Just leave it, that's all. b over 2 is just 7 over 2. 7 divided by 2 is just 7 halves. And then here, I square that. Okay, now when I square a fraction, that's anytime you're multiplying fractions, it's top times top, bottom times bottom. So if I'm squaring 7 over 2, basically I'm just squaring the top, 7 times 7 on top, and squaring the bottom, 2 times 2 on the bottom. So this turns into x squared plus 7x plus 49/4. Now, if I look at that and I'm thinking, okay, I have to factor that, boy, that's going to be hard to factor because I'm not used to working with fractions. No, it's not hard at all as long as we remember that we already know what's going to end up there. We already know that half of b is what goes in here. And since this was positive, this is positive. So as long as you understand the process or know the process and just trust the process, it's really not any harder. In a way, it could be thought of as a little bit easier because you don't have to, the difference is I'm not having to simplify this. If it was 8/2, I would change it to a 4. But if it's an odd number, just leave it. Let's try another one. All right. Good time to pause and try it yourself. I'm going to get half of -11 by doing -11/2. That's half of it. I don't have to simplify. And then that's going to be squared right here. So if I'm writing that out, that's x squared minus 11x. Now, it's going to always be plus, even though that was negative, because I'm about to square it. What's 11 squared? 121. What's 2 squared? 4. So there's my perfect square trinomial. And if I want to write it as a binomial squared in factored form, I'm going to have x. This is a minus, so that was a minus, so this is a minus. And that's it. If I were to multiply this back out, just like I did over here, I would get this. These are equivalent. These are the same thing written in two different ways. Let's try one last one like that. Actually, this time let's go ahead and solve. Let's say I had x squared. Let's make it an equation this time. Minus 9x plus, so plus 2 equals -12. That's the equation I want to solve here. All right, I'm going to solve it by completing the square. Let's go back to our steps. The first part, remember, is the preparation. So I'm going to make sure it's in standard form, it's equal to 0, and then I'm going to move my constant and put in my blanks. Okay, so this is add 12, that's 14. And then I actually want to move the whole 14 over there. I could have just moved it up here, but I'm following the steps as written. This is subtracting 14 from both sides gives me exactly what you see here. Now I'm ready to complete the square. This is where I take half of b. What is b? b is -9, so half of it is -9/2. And that's what gets squared and added to both sides. All right, so on the left now, I have x squared minus 9x plus -9 squared is 81. 2 squared is 4. And then over here, I have -14 plus 81/4. Okay, with fractions, this side really ends up being the only side where you have to do a little bit extra work. Okay, because all of this, remember, is going to factor as x, and then whatever I got for half of b goes right there. So that's what this whole side factors as. That's the factored form of this trinomial. Over here, to add numbers, when we have a fraction, we really need common denominators. So I'm going to think about -14 is what over 4? Right now it's over 1. So if I have to multiply this by 4, I multiply this by 4, and that will give me -56. So this is -56/4 plus 81/4. And when you're adding fractions and you have a common denominator, you just add the numerator. When I add -56 plus 81, this is what I get. Okay, and I did that one kind of on purpose so that this next step is going to be a little bit cleaner and tidier than it might otherwise be. I'm taking the square root of both sides because I'm trying to solve for x. So taking the square root on the left, it just lifts off the squared part. It undoes the squared part, basically. That's the opposite of squaring. And on the right, just like we said to square a fraction, we square the top, square the bottom. Same goes for square root. To do square root of a fraction, I can take the square root of the top. That's going to be 5. And the square root of the bottom, which is going to be 2. Square root of 25 is 5. Square root of 4 is 2. And now I still need to get x alone because that's the whole point when we're solving. So I get x is 9 halves plus or minus 5 halves. So the plus or minus means there are two things going on, two possibilities or two solutions. 9 plus 5, that would be 14 halves, which is 7. And 9 minus 5, which should be 4, which is 2. And those are my solutions. Okay, last thing I want to show you is basically the same problem, but what if back up here I had not been being asked to solve? I wasn't asked to solve. Instead, I was given this as a function and asked to write it in vertex form. How would that look different? Well, we could do exactly this. We could set it equal to 0 and do this whole step down to right here, not the square root, and then just move this back over so it's all on one side of the equation. Okay? Or we could do it, and this is probably how your teacher's been showing you, if you're doing that, like this. I'm going to set up my trinomial. There's my blank, so that I can square my trinomial and get a perfect square trinomial, And then over here, since we're not doing anything to both sides of the equation, if I'm going to add something, I'm going to subtract it back out here to keep everything balanced. So it's the same idea as doing it to both sides of the equation. It's just that we only have one side, so to speak. We don't have another side to keep things balanced. So if we're adding something inside the parentheses, we need to subtract it out here so that all of this really does equal the same as this. Okay, so half of -9 was -9 over 2, and that's what I squared. Same process. And this will factor as x minus 9 halves squared. And then over here, I've got 14 minus, and then this is 81 halves. Sorry, that's actually not halves, that's fourths, because 2 is squared. And then I'm doing basically 14 over 1 minus 81 over 4. And basically, it's all going to come out the same. I'm going to get -25 fourths. Okay? So what I want you to see is it's the same thing that we would have gotten if instead of taking the square root here, we just took this guy and moved him back over on that side. All right? So I hope this has helped you with completing the square. And in my class, we're getting ready to do that with circle equations. So that's another video I will be making soon, is how this applies to that particular context of the equation of a circle. You also have to complete the square when you're doing parabola equations or ellipse equations, what we call, or hyperbolas, what we call conic sections. So this is a skill that we need to know and use in lots of different ways. Hope it's helped. Thanks. Bye-bye.